All right, so here's some examples. Let's see, we get a chance to play with what we just learned here, and try to test these skills out. So here I could rewrite this sum as the sum. Oops, that's not a good one. The sum from 1 to 200. Right, start at 1, go all the way to 200 of I minus 3 squared. So we have a formula for I squared, right? We have a formula for I squared that we just saw, but we don't have a formula for I minus 3 squared. So what I would recommend is that you expand this, okay? And we have a shortcut. If you remember, it's a squared, excuse me, minus 2ab. So we'd multiply these together and double it. So that would be negative 6i. And then times this squared, right? Or plus that squared, excuse me. So it'd be plus 9. If you forgot that, you can always just FOIL this out. When you square a binomial, you have to multiply it by itself. So it's not just as simple, excuse me, as I squared plus 9. It's I times negative 3 times I, and negative 3 times negative 3. So that would get you the I squared. It would get you the positive 9. But what you'd miss out on is the negative 3i and the other negative 3i. And so when you combine these together, negative 3i minus 3i is how we get the negative 6i. Okay. So if you don't know the shortcut, you can always FOIL it out. But don't forget that you do have to remember that it's going to end up with a trinomial when you square a binomial. Okay. All right. So so now we get this here. So I'm going to rewrite this sigma notation as this. Oops. Okay. And what we can do is we can actually split this up, right? We can use our sum and difference properties and say, okay, well, let's do the sum from 1 to 200 of I squared minus 6 times the sum from 1 to 200 of I. Notice I use the coefficient property there, the constant. So where I just put the constant in the front because we have a formula for this. And then plus the sum from 1 to 200 of 9. Okay. So now we have formulas for all these things, right? Let's go back. So our formula for I squared is this right here, right? This right here. And so we can go and say, okay, oops, where'd that go? We can say that this is going to be n, which is 200, times 200 plus 1, right? So that's going to be 201, and then 2n minus 1, or 2n plus 1, excuse me, 2n plus 1, so that's going to be 2 times 200 is 400 plus 1 is 401. Okay, all over 6. Minus 6 times, now we have a formula for that, right? That's the one that Gauss used. So that's just going to be n, so it's 200, times n plus 1, so 201, all over 2, right? So that's this formula here. Okay, and then we have a formula for this, of course. So that's the one where, since it's a constant here, we just multiply n times the constant, right? So it'd be 200 times 9, right? And that comes from right here. Okay. All right, so we have all these formulas now set up. That's why we broke it up. And so now we can just evaluate these, right? So, so go ahead and evaluate this one. Plug it in your calculator or do it in your head. All right, and if you got 2,686,700, good work. So now let's do this next one. So go ahead and plug this in your calculator and see what you get. All right, and if you got, let's see, 120,600, good job. And then last but not least, we'll do 200 times 9, which is 1,800. All right, so now we can combine these values all together. So go ahead and do that on your calculator or in your head or on paper. All right, so if you got 2,567,900, good job. And so you just found the sum of this right here, right? All right, so that's how we use our sum properties to evaluate these sums, right? So we can kind of sometimes we might have to manipulate the function or the expression, whatever that expression is in terms of I, and then we can from there break it up into pieces that we have formulas for, and then evaluate with those formulas. And think about like counting this from 1 to 200 would be a lot, right? We could 1 minus 3 would be negative 2 squared, and then it would be 2 minus 3, so it would be negative 1 squared, and then it would be 0 squared, and then it would be 1 squared, 2 squared, 3 squared, 4 squared, right, all the way up to 200. And so that would be a lot of adding to do, and so this gives us a shortcut to get there, right? And we did have to do some work, but a lot less than having to physically add all the numbers from all these values from 1 to 200. All right, so for part B, so now we have the sum from 1, starting at 1, and going up to 6 of I cubed minus I squared. So this one just, at least from the start, seems a little easier to me, right? We can just use our difference property and just split this up like this, right? And then we can use our formulas, okay? So here we're going to use the formula for cubes, which is n squared, let's see, n squared times n plus 1 squared over 4. And then we'll use this one for the squared one, right? So we'll use both those formulas. Okay, so this will be n squared and then n plus 1 squared all over 4 minus, and then here we'll use the same one that we used here, which is the n times n plus 1 times 2n plus 1, so that'd be 12. 2 times 6 is 12, plus 1 is 13, all over 6. All right, and then we can just evaluate that. So when we plug this in our calculator, what do we get? All right, so we get 441, and then let's do this one in our calculator. And we get 91, right? Of course, these 6's cancel out, so it's just 7 times 13. And then 441 minus 91 is, and finally we get 350, okay? All right, so yeah, so that hopefully that gives you kind of a sense of how these problems work. So really just leaning on these formulas and kind of understanding how to manipulate and manipulate our expression to our advantage, and kind of manipulate the summation to where we can kind of get to the point where we can use these formulas or find something that's pretty easy to evaluate, right? And this one from 1 to 6 isn't too bad. So if you chose to do this without the formulas, that's totally fine. You can just plug in 1 and do 1 cubed minus 1 squared, then 2 cubed minus 2 squared, 3 cubed minus 3 squared, and so forth, all the way up to 6 cubed minus 6 squared, and then you can add all those up, and that's totally fine as well.